Recently, the Large Hadron Collider, LHC, published a paper describing the conversion of lead to gold. This transformation was metastable in the sense that the gold atoms very rapidly went back to lead or something else. But that's not what's important. We're gonna use this scientific discovery to demonstrate a stoichiometry type problem, a dimensional analysis problem. In other words, the kind of problem we work in chemistry all the time. So I'm going to take their scientific observation and try and apply it to something that we can relate to. Now, some data that we need. The conversion rate between lead to gold atoms, they were essentially producing 89,000 gold atoms per second. Okay? Now we're going to assume that that's a constant and that the gold atoms will actually stay around, that they're stable. So we're changing some of the parameters for this problem. Now what we want to do is, well, obviously gold is a very, very precious metal. It's it's the trading standard in many countries. In fact, I looked it up today. 3,321.55 cents per ounce is the cost of gold. However, you have to be careful about this, and I caught myself as I was doing the calculation. The regular ounce is about 28 grams. They use the troy ounce in measuring gold, which is 1 troy ounce is 31.1 grams. Whenever you're using an English unit of measure, you have to be very careful because there's more than one form of them often. In the case of the ounce, you have ounce for liquids, ounce for mass, then you have a troy ounce, which is also for mass, but specifically for gold and probably other precious metals. So we have to be careful about our units, and that's really what this problem is going to be about. So we're making gold atoms, and we can convert gold atoms eventually into money, right? In other words, that's kind of our goal. We want to see of how much money is being produced per unit time. But that's not good enough. We need a goal. So what we're going to think about is, let's say I wanted to purchase a video game for $40. Well, that's not good enough because if you're a real fan of your video game, you're going to pay $80. Okay? Let's not fool ourselves with theoretical games because, again, you're a real fan, not a theoretical fan. And this is real science, not theoretical science. So what we're going to do is we're going to calculate how long it will take to make $80 using the Large Hadron Collider making gold atoms. And so what we want to do is we want to know how many, let's pick a unit of time. And this is completely arbitrary. Let's go with days. Okay? How many days will it take us to raise $80 and achieve our status as real fans? Using this alchemy type of reaction, converting lead to gold, at a rate of 89,000 gold atoms per second. Okay? We've got a lot of information in front of us already. We are going to need a periodic table eventually. But the key with dimensional analysis is you have to have a mindset of, it's not going to be one step. It's going to take me multiple steps to get to my answer, and you have to know what is the unit of my answer that I'm looking for. This is one of the things that it's very counterintuitive when you're first learning dimensional analysis, unit conversions. So to solve a problem like this, I'm simply going to just put it down here, draw a line. Should be straight, but it's a little wavy. Put an equal sign after it. And now I'm going to put the unit of measure of my answer. Days, okay? You don't have to pluralize it. I'll just put it as a day, okay? Move that over just a little bit. So we have our target. We know that when all is said and done, to answer this question correctly, we need to know the unit of time, day. So that has to be our unit. Now we have to think about where do we start? Now with the line, this simply represents everything on top we're going to multiply by, everything below we divide by. Okay, it's that simple. But here is the biggest problem with dimensional analysis. Where do I start? Okay, well, I know where I'm going to finish. I know that my unit of measure that I want to solve this problem correctly is day, time. But what do I put in to get this problem going, right? I've got all of this information. I've got atoms per second, right? Gold atoms per second. I've got the cost of gold per ounce. I've got troy ounces. Eventually, we'll be looking at the molar mass of gold. So where do I start with? So we have to think about this problem. What's that one unique piece of information that's really driving the problem itself? Well, it's the cost of the video game. To be a real fan, I need $80, okay? If it was $40, that's what I would put in here. If it was $80, that's what I would put in here. If it was $110, that's what I put in there. And that is going to obviously affect our answer. These that I've given you, those are, you can think of them as constants. You can't really change these because, again, you can't change the number of atoms. That's something that's experimentally measured. This is defined and so forth. So really, the starting point for this particular problem is we're going to have $80. Okay? And now we need to get that into the unit of day. Now here's something that, let's say you make a mistake, and or maybe I'm making a mistake, and instead of putting in the amount of money that, as my starting material, as my starting point, let's say I put the number of atoms in, gold atoms per second. Sometimes you can get away with that. Other times it's 50-50. You'll find that you reach a dead end. And what that's telling you is that you started with the wrong term and it's inverted. In other words, you should be dividing by that term instead of multiplying. So if you start a dimensional analysis problem, you get 3 or 4 conversions into it, and it feels like you're trapped, you're at a dead end, you can't figure out where to go, take a look at your first step and ask yourself, is that the right unit? Is that what I should start with? And every problem is going to be a little bit different. So you have to kind of rationalize what we're trying to accomplish with this problem. We have money, and we're figuring out how much time it takes to generate that amount of money in gold atoms. Okay? So what is my first unit conversion going to be? Well, I can't use the gold atoms, even though that's kind of the heart of the problem, because this is just in dollars, right, in currency. But I do have a unit in currency. I have that for 1 ounce of gold, it's 3,321.55 cents. So I'm going to put that in. Now, units have to cancel. And in this case, I'm going to drop the cents, I'm going to drop the pennies, and just round it to 22. $3,322. And it's per ounce of gold. So that's for 1 ounce of gold. Yeah, AU is the chemical symbol for gold. Here's how you have to approach dimensional analysis. We have dollars divided by dollars, so those units cancel. Now I'm in ounces of gold. And again, it's troy ounces. I should probably put that, troy ounces. But that's not what I want. I want time. Okay, well, be patient. You do 1 conversion at a time. And if you trust the process, and if you're patient, you'll get to where you need to be. There are a few conversions we're going to need a little bit later on that I haven't written on the board, and I'll explain that when we get there. So how can we use any of this? Well, we know at some point we're going to need atoms per second, or we're going to need atoms of gold. On the periodic table, we have conversions for molar mass, which are in grams per mole. And this is where the chemistry part of this will really come in. But we're getting there. So I'm going to convert 1 troy ounce of gold to 31.1 grams of gold. Okay? Troy ounces cancel. Now I'm in grams per gold. And now we've got something that we can latch onto. If you're taking chemistry, you should be familiar with the periodic table. And we have molar masses. Gold has a molar mass of 196.97 grams per mole. Okay? So I'm getting that from the periodic table. Okay? By the way, from a significant figure point of view, this conversion is going to drop us the 3 sig figs. That's why I'm not worried about rounding it in some of the other stages. So how do we use this? Well, 196.97 grams of gold is 1 mole of gold. Okay? Grams cancel, grams of gold cancel. Now I'm in moles of gold. And I'm not going to go through the whole theory of the mole, but a mole is a way that we measure matter, so we can convert from atoms into grams, into things that we can actually measure in the macroscopic world. So we have moles of gold, but what we really need, well, we're still trying to get to time. Well, look at one of the things that we have that has time in it. Atoms per second. So now what we need to do is we need to convert from moles to atoms of gold. And that is Avogadro's number. We define 1 mole as 6.022 times 10 to the 23rd atoms per mole. So 1 mole of gold, okay, is 6.022 times 10 to the 23rd atoms of gold. Moles of gold cancel. Now I'm in atoms of gold. Well, look what we have now. From the very beginning of this problem with our Hadron Collider, it's generating 89,000 atoms per second. We have atoms of gold, so we can put that in. Okay? So 89,000 atoms of gold per second over 1 second, or 1 second over that. So now our atoms cancel, and look what we have. We finally have a unit of measure that is in time. Okay? It's the wrong unit of time, but we're going to get there. That's going to be pretty straightforward. But look what we've done. We've converted from dollars to ounces, ounces to grams, grams to moles, and then moles to atoms. And now, our final step, atoms to seconds. Okay? We want days. So, fortunately, we know some unit conversions pretty much by heart as far as time is concerned. We know that 60 seconds is 1 minute. Okay? So seconds cancel. Now we're in minutes. We know 60 minutes is 1 hour. Right? Minutes cancel. And we know 24 hours is 1 day. Squeeze that in. Okay. Hours cancel, now we're in days. Okay? Now, here is the most important takeaway as far as dimensional analysis problems are concerned. I know I'm correct. I've worked through with the units, and I want the unit of day. That's what I have. But notice what I have not done. I haven't picked up my calculator. At no point have I actually done the math. I'm going to need to multiply and divide these numbers, but that comes at the end. Okay? If you are solving a small problem, getting that number, plugging it into another, plugging it into another, plugging into another, you can still get the same answer. But with dimensional analysis, you effectively solve the entire problem. And look how many steps it took. So we have we'll ignore this. We have 1, 2, 3, 4, 5, 6, 7, 8 conversions. Okay? We did 8 conversions to get to our final answer, but we haven't picked up our calculator. So my setup is correct. Now I simply need to solve the numerical answer. And the way I'm going to do that, everything on top, we multiply across, and then we divide through by everything on bottom. And that will give us a number, which is going to be in the unit of days, and then that's going to be our answer. So I'm going to pick up my calculator and do that. Okay, I've done the math. So when we multiply 80 by 1, by 31, etc., and then divide by 3,322, divide by 1, divide by 196.97, etc., we get 2.98 times 10 to the 11th days. Okay? You can divide that by 365 to convert it into years, but basically it's going to be around the time either the sun burns out or the next GTA game comes out. So it's a very long time. 89,000 atoms per second might sound like a very large number of atoms, but it's actually an incredibly small amount of matter. 6 times 10 to the 23rd. You need to have that amount of atoms to start getting a significant amount of material to work with. And so what we find is anytime we're dealing with atoms, numbers in this case can be very, very large or very, very small. So don't be intimidated if you get an answer and it's, like in this case, 10 to the 11th. That is correct. So, real fans of video games, take heart. You just need to be a little bit more patient, a little more hardworking, and just keep grinding it out till the end of time. All right.